on your window, when you graph polar equations, theta min, 0. That's where you're going to start graphing from, 0 degrees. Theta max is what degree you're going to stop graphing on, 360 degrees. Remember when we graphed those by hand, we started at 0 degrees, and I had you guys go clear around to 360 degrees? Although I think for this class, you guys only had to go to 180 degrees before it started repeating a pattern, right? A lot of them start repeating a pattern. Now, 7.5 means they chose a point every 7.5 degrees and plotted a point. So they put in 0 into the equation, then they put 7.5, and then 15, because that's 7.5 plus 7.5 is 15, and then 22.5, and then they connected. Remember how I had you guys do it every 10 degrees? Remember when you guys did it? Well, it puts a point, and then it connects the points, just like we did. It connects the previous point to the next point. Does that make sense? Yeah, it's not going to be a smoother curve. If you want smoother curve, you'd be doing less steps. The problem is it takes a long time to graph it that way. So like we could go every 5 degrees. You want to go every 5 degrees? Everybody change it to 5 degrees. It'll make it a nice smoother graph. Okay? Then x min just is the same as on the rectangular coordinates. So it just means it's going to go 10 units to the left. X max is 10 units to the right. X scale means it's going to put a dash at every 1 unit so you can kind of see your radius. And then if you keep going down here, you have a Y min, a Y max, and a Y scale. Same thing, okay? So, Dylan, did you have a question? Okay, good. All right, so now you guys, we go to Y equals, oh, we're going to go to Y equals right here. Notice, since I put in cosine of theta, when we hit the graph, it does a very small circle right there, okay? Let's do this. We can either change our window and make our window so it's smaller, so the graph looks bigger, or we can just make the kind of the radius a little bit bigger. Okay? Let's insert 8 right there. Okay? So 8 cosine of theta. Graph that. And there's a circle. What's the radius of that circle? It's 4, isn't it? Do you see that? The diameter is 8, right? Now, why does it not look like a circle right there? Why does it look like an oval? Okay, let me explain this, because I always get asked this question. Because you guys say, well, it's supposed to be... Are you guys listening? You guys all ready? Listen. Okay, the reason it's doesn't look like a circle is because this calculator is rectangular. The screen is. So it stretches out to the left and right further than it goes up and down, right? So it kind of distorts the circle. Okay, but it really is a circle. If we made a square screen, what? That's because you're in radians. Yeah. Make sure your calculator is in degree mode. Everybody, right now, go to your mode button. Make sure you have degree mode and polar mode. Those two things right there, like mine. Has everybody got that? Yep. Okay. Now, you guys, now this is the next thing I want you to do. I want you to now graph it so it has the same radius, but I want the circle to be over here. Got it? See if you can do that. I want it to be where the red one is. Okay, good job, Bryce. McKay had it. Okay, Bryce, what did you get? -8 cosine of theta. So if we go back here, I'm going to erase this. And we're going to go second insert negative. And there's -8 cosine of theta. Any questions? Okay. How would I make this circle be right here? That's where I want the circle next. You got it, McKay? All right. McKay's got this figured out. Rachel's got it. Good job. Yeah. That's pretty good for drawing it, huh? Every once in a while I get lucky. All right. Yeah, I did. I've had lots of practice over the years. 22 years of practice drawing circles. All right. Okay. Who thinks they've got it now? Okay. McKay, what did you put in your calculator? Okay. So you probably took away the negative, right? And then change the cosine to sine. Okay. So just 8 sine of theta, right? So can everybody figure out how to get the circle on the bottom now? Negative 8 sine of theta. Okay, we got that one. Okay, that's how you graph a circle. I would suggest writing this down. Circle where radius is on an axis, okay? I would write something like R equals A cosine of theta, or R equals A sine of theta. This next test, you will not be able to use your notes, but you can make a 3x5 card. I would suggest this be on your 3x5 card, these things that I'm showing you today. This test, you guys, I'm telling you what, half the students in my class usually get 100%. Half that don't get 100% is because they did take a little time to review before they took the test and make a 3x5 card. If you'll make a 3x5 card and review these graphs before you do it, review how to plot points. Also, we're going to learn a few other things. You'll get 100% next test. So those of you who want to raise your grade, I'm not going to, no, it's not going to be guaranteed. It depends on if you study or not. It would have been hard if you wanted to spend some time. Well, I made it pretty easy. I shouldn't have made it so easy. All right. Okay. All right, next one. Next one. We are going to graph what we call a lima. I always call it a limacon, but I heard it's pronounced limachon or something like that. Limachon. Okay. So this one, we are going to do this right here. I want you to graph R equals, go to your Y equals, R equals 3 minus 5 cosine theta. And graph that. This is called a limachon with an inner loop. Okay? We're going to do spirals in a little bit. We're working our way to them. Okay, Y equals right here. 3 minus 5 cosine of theta. That's an example. How do you think I could get that to be on the positive x-axis instead of the negative x-axis? Try it. See if it works. I want to change this over to the right side so it's on the positive x-axis instead of the negative x-axis. Okay? Someone said change that to a plus, 3 plus 5 cosine of theta. If I do that, this is what I get. It's on the right side. It's on the positive x-axis. Okay? It's called I'm going to just call it a limacon. That's what I've been calling it for years. So, but you probably seen, if you ever looked up the pronunciation, it's different. Okay. How do you think you would make it so it's on the positive y-axis? How do you make it so it's on the positive y-axis? Okay, so change the cosine to a sine, you guys say? Let's see what happens. It's now on the positive y-axis. Now, let me ask you guys this. What happens when you start playing around with those numbers 3 and 5 right there? Nope. Okay, let's do something like, let's make that a 2, and let's make this a 6. Let's see what happens. Okay, the inner loop is a little bit larger. That's how you say it, the inner loop. Okay, the inner loop. Hey, what happens if you make the first number bigger than the second number? Okay, what happens if you make the first number bigger than the second number? Let's say we went 5. Ramona, it's unfortunate you had to learn your English in southern Utah. Right? Just kidding. Huh? He says you don't. It don't. It doesn't. Doesn't. You were talking like Addie there for a second. That's why I was saying. Okay. All right. To buy you, huh? When he should have said, I can't remember what he said now. He should have said, it doesn't. It doesn't. It does not. It don't. Okay. Okay. Okay, so it just makes one of those circles, right? Let's call the limacon without an inner loop, you guys. Without an inner loop, okay? So we know how to change them left and right, up and down, and all that stuff, right? Okay, next one. Oh, well, you guys, what's the equation for that? Let's write it down. Okay. This is R equals, and let me use the same letters I used in here so we just get it right. A plus B cosine of theta. Or R equals A plus B sine of theta, right? And those make the inner loop. And in this case, you guys, to get the inner loop, what do you have to have? A bigger than B or B bigger than A? B is greater than A, right? The absolute value of B is greater than the absolute value of A. Okay? And to change it, you just change the plus to minus. Change it to go down or left, you change the plus to a minus. You might want to write that down as well. Okay? If, see that plus sign right there, Addie? Change it to a minus sign, what does it do? Yeah. Well, if it's a cosine, it moves it left. If it's a sine, it moves it down, right? So it's down the negative x-axis. That's a good question. We're going to do that one in just a little bit here. Let's see. Okay. Let's do what we call a cardioid. Cardioid. Okay. What is a what is the? Yeah, it's a heart, right? This is going to make a heart shape. Okay, and this one is when you have r equals a plus a cosine of theta, or a plus a sine of theta. Whoops. Oh, wow. How did I do that? A plus a sine of theta. So let's say I wanted to have a heart. Like I'd do 5 plus 5 cosine of theta. Where's the heart going to be? Actually, not in the middle. To the right side, along the x-axis. Does that look like a heart? It doesn't point very much. It looks more like a peach, right? Okay, any questions there? Okay, how would I move that? How would I make this one down here, you guys? So, how would I make it down on the negative x-axis? Huh? 5 minus what? That's exactly right. 5 minus 5 sine, and you would get a cardioid that has its a pumpkin or an apple. All right. Okay. Okay. Okay, Addie, we're doing this. Okay. What? All right. Now, so we all know how to do a cardioid, right? Okay, the next one. Yeah. The number has to be the same to make a cardioid. Okay, we're almost done learning stuff, yes. Okay. Oh, hey, I want to make a rose. Okay, let's do this. Make a rose with 8 petals. First person that does that, I'm going to give a piece of candy to. A rose with 8 petals. What are you going to put in? 4 theta. What's the rule? Hey, what's the rule for getting an even number of petals? The number you put in for theta. Yeah, you're welcome. Okay, so to get 8 petals, you guys, the rule is you have to put that number that goes by theta is half the number of petals you want, okay? Why doesn't it do that with odd numbers? Exactly. Hey, you guys, listen. This is a very important point. Why doesn't it do that with odd ones? And Ramon answered this because the second time it goes around, the first 180 degrees, it does the first 5 petals. Like if I had the 5 petal one, and the second time it just retraces those 5. Whereas on an even one, they're all separate petals. Does that make sense? So it still traces on if you want 5 petals, if you put a 5 in, it's going to actually give you 10 petals. But it looks like 5 because it retraces half of them over. Okay? So you got to remember that rule for the test. Hint, hint. You might want to write something down about that. Okay, so a rose, we call them, the official name in Polar is rose, and it's y equals a cosine of b theta, right? Oh, well, yeah, r, sorry. Let me actually, you guys, before you write that down, let me see what the book uses for their letters. So in case you look it up in the book, r equals a cosine of n theta. Okay. They use n instead of b. R equals n theta. R equals a sine of n theta. If n is even, there are 2n petals, right? If n is odd, there are Got that? Okay, someone said someone made a spiral. Sean? Okay, did you? I want to know if you can make a spiral without even using any trigger things. A spiral. Huh? Without either using sine, cosine, tangent, cosecant, cosecant, cotangent. Make a spiral. It's actually very simple, but I won't give it away yet. Okay, you got it? Huh? If this thing, if n is even, there are two n petals. That means there's twice as many petals. Like, if n was 2, there would be 2 times 2 petals. Yeah. When you put in 4, there's 8 petals. If n is an odd number, like 5, then there's only going to be 5 petals. Got it? I don't know if I recorded the spiral for these guys, but that's pretty good donut. We call that the donut. We're gonna name it after Andrew. The Lester donut, or something like that. All right. You could coin your own polar equation right there. All right. Okay, you guys all know how to do spirals. So a basic spiral would be like theta divided by 100. And you could do that. That would just make a spiral. And you. That's because you didn't change your window. See, mine's still going, even though I can't see it. It's still going out there in space. I'll wait till mine stops. You can see that little worm up in the top right corner. Mine stopped. So if you go to your window, you got to change your theta max to something larger. You only went around the circle one time, 360 degrees. You got to keep going around. Yeah. Okay. Okay. What is it? No,
the student has become the teacher.
Yeah. Right. No. Oh, I don't give you. I give you circles and cardioids and cool things. That's just a bunch of scribbling. Huh? Oh, that's awesome. Now come and do that one for us. Come and do that one for us. Okay. Jay's going to do one for us here. Oh. That's just going to do it.
Oh my.
That was pretty cool. I have to say that. That was pretty cool. Yeah, I did. There's symmetry to that one. Now, why is theta divided by 50 in radians going to do that? I don't understand that one. But.
Probably goes really fast.
Huh. All right, that's it. Oh, your assignment. Your assignment, you guys. Okay, lesson 9-2. Page 565. I want you to do 11 through 13. 15 through 19. 21. I am today. Through 23. I usually don't. Okay, that's it.